Good. Well, my name is James Bach. I'm going to talk about testing today. Has anyone here ever studied testing at all? Taken a class in it? And raise your hand if you've taken a class in testing. I know you have, Oliver. You've taken a class in testing? You're taking it now. There's a class in testing right now in school?
Anthropology and standards.
Standards, okay. That's useless. Totally useless. You don't learn anything in there that you will ever use again to actually help society do anything. And I am absolutely serious. It is completely useless. If I had my power, if I was empowered by the United Nations, I would abolish classes like that. But you might want to humor the professor, don't tell him I said that, or he'll feel really bad. But actually, it's completely useless. And what the ideas that are used in that class are 30 and 40 years old, and they didn't work 30 and 40 years ago. They don't work today. They didn't work in 1990 when I first criticized them and was first ignored by the people who were using them. And they didn't work in 1995 when I criticized them again in writing and in conferences all over the world and was still ignored by the people who used them. No, I'm going to talk to you about testing today. I'm going to talk to you about real testing. So get ready. All right? A little bit about my background. First of all, I love the sign that says Dr. Bach. I'm a high school dropout. I'm not a doctor. I am opposed to the whole idea of PhDs, as a matter of fact. So I love getting little pictures of these signs because people assume I'm kind of famous as a tester, they assume that I must have a great deal of academic achievement. But no, I'm an academic revolutionary. I'm the only high school dropout who's written a book about being a successful high school dropout. Okay, not a lot of high school dropouts do that. I started when I was 16 as a video game programmer on the Apple II and Commodore 64 right after I dropped out of school. Well, not right after. I went through a little stint as a computer salesman, and I was the worst computer salesman ever. I never sold a single computer, and I broke one. So I'm -1 on computers, selling Apple II computers in 1982. And then a guy walked into the store one day and said, "I'm looking for programmers. Do you know anyone who programs?" And I said, "I program." And I showed him this little program I wrote in assembly language. All it did is it made dots fly around the screen. That's it. That's all it did. And he said, "You're hired for $1,000 a month," which to me was a princely sum at that time. So I became a video game programmer. I did that for 4 years. Then Apple Computer hired me. I was the youngest manager at Apple Computer when I joined Apple Computer as a test manager. Having never tested before and never managed before, Apple Computer hired me anyway, which tells you right there how screwed up the testing industry is. Because you don't see that so much in hospitals, that people are hired to be managers of doctors and don't know anything about doctoring. But I was hired to be manager of testers. And so I decided I better learn testing. And I read every testing textbook that I could find. And about 6 months later, I looked around the 400 people in the group, the building where all the testers were at Apple Computer, and I realized nobody is reading testing textbooks but me. I'm exaggerating a little bit. There may have been 10 people at Apple Computer total who were reading testing textbooks, but it was mostly me. And I found out why later on. They're all useless. The books are useless. They're written by people who don't understand how to test, but it's okay because no one else understands either. So people who read them don't know that they are full of misinformation. The people who write them don't know that they're giving misinformation. And if you find this a little bit incredible, I want to remind you that in the world of medicine, for more than 1,000 years, Galenic medicine ruled Europe. Galenic medicine, like where you bleed to cure all kinds of ills, and where there's 4 humors that make up the human body. You got your black bile, your yellow bile, your phlegm, and your choler, and it's the combination of humors that lead to all sicknesses, right? And they had certifications in this all around Europe. You know, you had to go to school and learn to do this medicine that doesn't work. It never worked. But for 1,000 years, that was the best practices of medicine. Until when? Until some people, after the scientific revolution got started saying, hey, wait a minute, this stuff doesn't work. What really is going on in the human body? And in the last 300 years, the entire world of medicine has been revolutionized because people started saying no to the textbooks that were wrong. And that's what I'm doing now in the testing industry. And I'm fighting a whole bunch of people, especially in Europe, which they're saying this Galenic testing medicine is the best practice, and you have to bleed your software, and all software testing consists of yellow bile and black bile, and I'm trying to say, no, it doesn't work. So I stand before you to try to reframe things for you, and thus create even more trouble in Europe. So if you were expecting something different, ha-ha! All right, let's get started. Let's take a look at this. Here is a simple flow chart. And I want to start very simply here and just ask you a question. If you had to test something represented by this flow chart, how many test cases would this take? Can anybody call me an answer? 2. Why 2? What are the 2?
Yes, no. Yes, no.
You want to do yes and no. And what will that accomplish by doing that? All right, so you will have achieved what they call, do you know the technical term for what you've achieved? You've achieved decision coverage. You've also achieved predicate coverage. You've also achieved all path coverage by doing that. So there's 3 kinds of coverage just by doing 2 tests. Anyone else have a different answer than 2? Or do you accept 2? Yes. What are the 5 you'd like to see? Not 5 tests. I'll repeat whatever you say. You're thinking about it. Something is telling you 5. There's an intuition.
One possible is A is 70.
Yes.
And
If A is 70, that's an interesting test for you. Okay.
A is less than 70.
Less than 70. Well, they chose that.
Is yes.
Yes.
Should be no. And then when it's more than 70.
So then there's 3. Less than 70, equal to 70, and more than 70. Where are the other 2? If you have A is less than 70, A is equal to 70, and A is more than 70, are there 2 more? No, so it's 3 for you. So you've added a new kind of coverage, boundary coverage, because A equals to 70 is a boundary condition. And now that is redundant to the coverage that these 2 young gentlemen have suggested. Their tests are going to cover the same paths, the same decision, and all that. And you've just added one additional thing. It's just making sure that the behavior right exactly at the boundary is going to work correctly. Of course, you could still do it with 2 tests, because all you have to choose is A equals to 70 and A equals 71, and bam, you've done her coverage, and you've still done it in 2 tests. So you could do this still in 2 tests.
Not really. It's not small. She's right, as it's smaller. You know, A is smaller than 70, but not smaller and equal. So what if it equals?
You mean what if the code actually says A is less than or equal to 70 instead of less than 70?
A is smaller than 70.
Yeah.
But what if it equals?
Yeah.
It's not smaller and equal.
Oh, yeah. So actually, it's a good point. So I misspoke. It's because I changed this exercise last night. So I have to up. This is the first time I've ever done this exercise in public. This is my beta test of this exercise. So it actually has to be A is 69, and A is equal to, no, A is equal to 70, and A is 70 and 71, because less than 70 No, that would have to be 69. Right, 69, and then 70. 70 is going to take the yes thing. Okay, yeah, right. No, 69 takes yes, 70 takes no. Got it. Less than 70 there, greater than 70. Okay. I think that's backwards. I think that's supposed to be greater than 70, come to think of it. Okay. Now, this illustrates one issue in testing right away, which is that your model may not represent what your idea actually is. And so that's one aspect of what testers do. Testers question models. But let's move on from there. And let's say that I meant to do that. A is less than 70. Now, you still have two tests that you can cover both of these things, and one of them can be an equals case. So then the question is that enough? Is that anyone else have another test you can suggest? Yes, call it out. Green guy. You're not wearing green. I'll ask you next. Yes? Now, how is that going to cover something that's not already covered? Bigger than the long integer, bigger than the longest possible integer. So, in this case, bigger than what, 18 quadrillion or whatever it is. And how is that going to cover a new path? So, if it doesn't cover anything new, why are you doing it? Where would the error be? Where's the error? How could there be an error? Is there anything here that's checking the long int? What? Your intuition is telling you something, and your intuition is correct, but you can't yet put it into words, so you're going to get a good half point for that. How about you, sir? Do you have an idea for another? A might not be a number. Well, so what? So what's going to happen? What happens if A is not a number? Which path does it take? What? Do you think it doesn't take a path? Or do you think the system interprets it as a zero if it's not a number? In the Perl language, if you give a non-number, a alpha string to a numeric routine, it just treats it as if it were equal to 0. So it would take the less than path and it would just stop. But you don't know? So why do we have to do this test? Because you don't know what language it's written in, so you want to do this test. You just want to see what happens. So you're not trying to test a new path. You're doing something else, or are you actually testing a new path by doing this? You're not sure anymore. Okay. You too have an intuition, and it's a very important intuition. And in my view, your intuition is correct. You don't yet have the ability to explain and defend your intuition. That's okay. That's what training testers is all about, getting them to not only have these ideas, but to be able to explain and defend these ideas. But both of you are on to something. Both of you have added something that's not here. Both of you have brought something to this that is not explicitly in this model, and that's something that testers must do. Anyone else have any kind of idea of what we can do to test this? Yes?
Well, just the same idea. There's a third path that's missing. The third path from A is not a number. So the model is incorrect because A can be not something else than a number.
So you think the model's just flat out incorrect. It just hasn't accounted for something.
It's missing a third path.
It's missing a third path. Okay. Or the third path is somewhere else. It could be that it doesn't need a third path because the input gets filtered somewhere else and never anything other than pure, clear numbers come through that are already underneath max int because they're 1 byte values from 0 to 255, for instance, which I happen to know is the case. So if I know already that 0 to 255 is the only thing that's ever going to come through here, then what are we worried about? There doesn't need to be a third path.
In that case, no, yeah.
Right. Okay. So, anyone else have a comment on this, on any of this? Or is there anything you want to say about how to test this?
Well,
Yes?
one idea, if we store it in database, then maybe we must have this feed type for it. If it's a float number, then
Oh, it's just a single byte integer. It's just a single byte integer. You think the storing might go wrong?
float number will be less than 70, and we can't store it on an integer type of feed, for example.
Okay, good.
And this test is actually very important because it won't be stored at all. But,
Okay, so you're questioning the storage stuff. Okay. All right, well, let me tell you something that several of you have implied, but you're not saying outright, and I want to say it outright for you. This is not the system that you're testing. This is a picture. And pictures aren't the systems that you test, or if they are the systems that you test, they are a tiny, tiny part of the system you test. Testers are not here to make up stories about rumors. We're here to encounter reality. That's what testers do. They discover the ground truth. Somebody gives me something like this. You know what my first impulse is? My first impulse is, what is this thing? Can you tell me about this, please? What is this? What's going on here? So let me give you a little extra information about this. This, a fully qualified context-driven tester would do. They would say, well, I don't know how many test cases it would take. I don't even know if that's a reasonable question, but I'll tell you, if I'm figuring out how to test it, first thing I want to know is, where am I? Did you just kidnap me, put a bag over my head, bring me to an undisclosed location, whip the bag out, and now I'm staring at this flow chart? Probably not. Probably I know something about what's going on the project. So if you pose a testing problem to me, to make it a realistic testing problem, I've got to ask, you have to tell me what's going on the project. Here's what's going on in the project. This code that I've asked you to test, it's part of an experimental system, okay? It's supposed to defend a spacecraft from space junk. It's part of this elaborate defense radar system. Okay, the system continuously evaluates potential threats, and there's these 50 processors that are running, continuously evaluating threats from a threat server connected to all the radar dishes, and then stores them in a threat database, which is then handled by another system. So this is the system that does the filtering. The code I just showed you is running on each of the 50 processors simultaneously. Okay, now that you know that, you might have different ideas about how to test it. You might do things like, well, let's saturate all the processors. Let's get a whole bunch of threats going here and see what happens when this code is running on all these processors at once. Now that we know that it's a distributed system, and it is a distributed system, there's ground-based radar systems, and there's a system on the spacecraft itself, and data flying all over the place. Well, now what you should be doing is asking yourself, well, what's going on? Well, first of all, who calls this? Let's find out what the calling context is by clicking on this. Okay, so there's this infinite loop. Well, that's a problem right there. Maybe you want to exit this system once in a while, take it down for maintenance, but there's no way to do it other than to, cut the power? If the processor is available and data is waiting, then create a new processor object, run the threat tester program, which is the program that you just saw, and then kill that processor, which hopefully will free up all of its memory and restore it to a state of readiness, but maybe it won't. That's another part of our testing. So that's what's happening outside of this routine. Let's look what's happening inside each of these boxes. You have this box called input A. Well, look at all the things it's doing. You have to establish a connection to the data server, acquire the next data record, handle any errors. Then there's an analysis process that comes up with a letter grade, which is that single byte value. This process takes between 25 milliseconds and 10 minutes to do for each threat. Translates that into an ASCII code, which is the explanation for why I use 70 there, because I'm looking for letter codes that are from A to F that we want to store. Except this is reversed. This should say greater than 65 and less than 70. So I've actually messed up the program, which that, by the way, is a real bug. I actually didn't. I put stuff in here that are fake bugs, but that is a genuine mistake I made, which just proves my point, doesn't it? That you should never trust any picture a developer shows you. They say, here's my intent, and you can look at it and go, is that really your intent? And they go, oh, yeah, I always reverse those greater than and less than signs. And isn't it a good thing that the tester asks about that? Isn't it a good thing? That what it means to be a professional tester is to be a professional skeptic. We are not in the belief business. We are in the observation and inference business. You want the belief business? Become a marketer. Become an academic. But you want to be if you want to be a tester, then when people who are in positions of authority tell you things, you don't believe what they say, ever. I honor what they say, but I don't believe it. I use what they say, but I don't believe it. Belief is a sin for testers. Now, I hope that you're getting the idea that each one of these boxes might have a little hot link and might have some additional information. Like if we look at the actual code here, we say that it's, less than or equal to 70, and look what it is. This is the opposite of what the flowchart says, because this says it's going to store the threat, and it doesn't just store a single byte, it's storing the whole threat record. It's actually it's sending the threat handle, which then copies the whole threat record, so it's not just a single byte that's being stored. This whole idea of store A is an oversimplification. It's like pseudocode. The developer is just giving you shorthand, but that's not really what's going on when you look at the code. And also you see that it's less than or equal to, so that's just completely wrong. What does the storage mean? Well, we have to establish a connection to the server, wait for credential validation. You might think here, why is it designed for credential validation on a spacecraft? Are you really worried about space hackers here? There might be a performance issue there. Okay, so there's a bunch of things that are happening. Anytime you see a box in a diagram, you have to ask, what's going on inside that box? A box is an abstraction. Okay, here's my point. First of all, 2 test cases? What are you, crazy? I know why you said that. You said that because you took some kind of class, and in that class, some professor is talking about what's called basis path testing or decision coverage testing, and that's the correct answer on the ISTQB thing, okay? And ISTQB has nothing to do whatsoever with practical software testing. It has to do with making money for consultants. That's what the ISTQB is all about, making money for certain consultants. Now, I make my money partly by attacking the ISTQB, so indirectly it makes money for me too. But the difference is I admit it. So, here's the bottom line here. Let me just bring this up if this works. Here are the lessons. Okay, the concept of how many test cases is generally speaking a useless and stupid question ever to ask. That's like saying, how many files will it take you to write your novel? Well, I don't know. I might save different drafts of my novel in different files. Let's see. I might make a backup draft every couple of... Wait, why am I even answering this question? What a silly question. That has nothing to do with my productivity whatsoever to ask me how many files is it going to take me to write my novel. That has nothing to do with writing a novel. That is an irrelevant technical detail. And it's an irrelevant technical detail to count test cases. That has nothing to do with the essence of testing. If I happen to think about it or break it down one way, it's going to be 149 test cases. And if I break it down or think about it another way, it's going to be 3 test cases. And there'll be the same testing either way. It's just a matter of what I decide to put in a file, basically. So that's a silly question. The better question would be, how should you test this? And if you're going to answer the question, how should you test it, number one, first thing you have to do, learn the product. Learn everything you can about the product. You know what testing is, apart from professional skepticism? Software testing is rapid learning. If you love to learn about new things and you get bored when you know about something and you want to move on and learn about something new, you're probably going to be better at testing than at development. Because in development, you're slogging through the same thing day after day, week after week, month after month. You're still working on the same code. God, make it stop. When I was a developer, I hated being a developer. It's like I was good at solving crossword puzzles, and someone says, you know, you can make some money solving crossword puzzles. And I'm like, whoa, make money solving crossword puzzles? It sounds like some kind of scam. So I start doing it, and I find that I have to solve like 25 crossword puzzles a day. And after the first couple of days, it's like, man, I'm sick of crossword puzzles. And it's oftentimes almost the same crossword puzzle with slight little differences. I am so bored. I used to love crossword puzzles. Now I hate them. I hate them so much. But with testing, it's not like that at all. With testing, it's a new problem all the time. I love the variety of testing. And a lot of people think there's no variety. A lot of people think, oh, testing, it's such a boring slog and it's all repetition. It's kind of like sex. If it's not fun, you're not doing it right. You're doing it wrong. If you approach testing not as the most challenging intellectual exercise you've ever done in your life, then you don't understand testing, because that's what it is. And yes, there's some repetitive stuff in it, but even within the repetitive stuff, there are clues, subtle clues, if you are smart enough and observant enough to see them. That's why I love testing. And I also use my development skills in testing. Now, you don't need to be a developer to be a tester. Being an ex-developer, I write my own test tools. But you don't have to write your own test tools. All you have to do is make friends with someone who is a developer who will write test tools for you. So you either need to know how to write test tools, or you need to know how to be charming and manipulative. And then other people will do that work for you. Either way, you're covered. So in real industrial life, nobody has all the skills, and that's okay. In real industrial life, you either have the skills, or you're learning the skill, or you're friends with someone who has the skill, and you borrow their work. And that's, in industrial life, not called cheating. That's called professional behavior. In academic life, it's called cheating. That's yet another reason why academic life has so little to do with the reality that after your academic life. So in industrial life, it doesn't matter whether I solve the problem. What matters is I get the problem solved, no matter what the problem is. And I'm usually working with a group. So when I come into a situation, I size it up the way Miyamoto Musashi, or is it Masashi Miyamoto? I never know which of his names is his first name. But there's a guy, he lived in 1645. He wrote a book called The Book of Five Rings. And the Book of Five Rings is all about how to win duels to the death. He starts out his little book, which you can read in 45 minutes. I have survived 60 duels to the death. Here's how you can do it too. And he basically says there's no one right way to win a duel. You do whatever it takes to win. And he makes fun of people who think that there's the best practice of using one sword, or the best practice is using two swords, or the people who are in the Morning Star School and the Mace School and the Short Sword School or the Long Sword School. And he said, ha, they're all wrong. Here's what you should do. Learn every weapon. And then use whatever it is that puts your enemy at a disadvantage, including furniture. He has a whole section on using furniture to defeat your opponent. And that's my attitude, too. I walk into a situation, a technical situation, as a consulting software tester, very highly paid. I'm generally paid $300 an hour or more. And most I've made in my career, if you're interested in what the career of a tester might be like, most I've ever made in a week is $35,000. I made $35,000 a week for 12 weeks once in 2002. And it was very depressing, by the way, because I knew at that moment I was making more money than I would ever make again, probably in my whole career. And that's really depressing when you realize that, because you know you're going downhill after that. But it was a multi-billion-dollar court case, and they needed to get the best tester they could find, and they thought that it was me. And I decided to let them believe that and try to be the best tester that I could possibly be. And it was very, very exciting. But what I do when I walk into a situation like that, you know, I'm very highly paid, people are depending on me, I size up everyone in the room. Everyone in a room is a test tool that I'm going to use. If you know something I don't know, congratulations, you're my new test tool. I will use you. I will find a way. What is it? What's your price? Chocolate brownies? What is it? Money? Women? What is it? I shall bribe you with whatever it takes. Do I have to smile at you? Do I have to offer you respect? I will do whatever it takes to get you to use your skills on my behalf, because I am a rapid software tester. I took my lesson from the Book of Five Rings. I use any tools available to solve the problem. So it is not true that you need to have every skill. But I agree with Musashi that we should be constantly developing our skills throughout our career, all kinds of different skills. So I might not know how to run a tool for a time being, but if I turn out to need to run that tool for any period of time, I am going to study that and I'm going to get good at it. And that is just an ongoing process. It's ongoing self-education. Okay, so a better question than how many tests is how should I test this? And a tester must always seek the underlying complexity beneath the apparent simplicity. That is one of the essences, I would say. One of the essences of software testing is testers seek to dispel illusions. So, that's my little opening thing. And now I want to do a little presentation for you which talks about some of this stuff. This is a different presentation. This is a presentation I do usually for developers and for managers. Hello, I'll be your tester today. Introducing you to the great and marvelous art and craft of intellectual software testing, of using every neuron in your brain to test stuff. Okay? So, here's an example. Let me give you an example. Now, I want you to listen to the words that I use, to how I'm using words as I describe what's going on here, because this is a key to one of the aspects of professional intellectual testing. Years ago, I was in the lobby of the Del Coronado Hotel in San Diego, California, and I was about to go on stage to speak in front of several hundred people at a conference for Intuit. It was an internal Intuit developers conference, and they wanted me to speak on the subject of good enough software quality. So I thought I would gather some fresh information while I was there. So I'm in the lobby of the hotel, just wandering around, and I see this Dell Discover Club kiosk, and it's this thing with a little keyboard and a mouse, and I thought, I know what this is. This is a tester workout station, and I'm going to do a little testing workout right now. So I plunge in, it's called a pick cycle. I decided to do a pick cycle, a plunge in and quit cycle on this. And so I just approach the system and I begin to interact with it. I click on it and I see this. Immediately when I see the fields, I'm thinking input constraint attack. It's a natural thing whenever you see fields. So I decided to do some input constraint attacks. As part of that, I'm going to use a little trick. And then I'm going to type in a few characters. I'm going to go Control A, Control C, Control V, Control V, Control A, Control C, Control V, Control V. So if I just hold the Control key down and just go A, C, V, V, A, C, V, V, A, C, V, V, every time I do that, it doubles the input. Pretty soon I've got several thousand characters in each of those things, and I say submit, and it seems to accept it. There doesn't seem to be any performance issues. So I shrug, and I decide to defocus, and I do a little click frenzy. I do a left click frenzy, I do a right click frenzy. When I do the right click frenzy, a click frenzy, that's where you move your wrist like so, and move your finger like this on the mouse clicker button, and just click all over the place. Just go crazy with the clicking, okay? That's one of the many quick test heuristics that I use. Well, when I did the right click frenzy, look what I found. Now, when I see this, I immediately think rumble strip heuristic. Am I right? The rumble strip heuristic. Now, the rumble strip heuristic, that means that just as on the sides of highways, they put the corrugated strips of bumps so that when you are driving and you drift off the highway because you're falling asleep, your car starts vibrating. You've ever seen that before? They have that here? Or do you guys just fly off the highways? Well, in civilized countries, anyway, what happens is we value life. And it starts vibrating. And when your car vibrates like that, your first thought isn't, I can live with this. It's just a little vibration. Now, your first thought is, I'm flying off the road, wake up. So a rumble strip heuristic in testing means that often when we see small problems, we get excited because it means there's a bigger problem about to happen. And boy, I want to see that happen. So I want to pull the steering wheel even farther and see if I can get this thing to fly off a cliff. All right? So I see this. It's not a big problem, but it's an empty error message. And that means the developer maybe was falling asleep at the wheel there. So maybe this developer hasn't fully thought through the code that's involved here. So that leads to something called error message hangover testing. It's like a hangover. The error message is a big party, but then now your place is a mess, and there are people sleeping under tables, and there's tables outside in the lawn, and broken glass, and you got to deal with your hangover. Okay, so I think that it's probable that something after this error message might be messed up. So I'm going to try to do stress testing on this because that'll exacerbate whatever the problem is. So I'll use a variation of a shoe test. A shoe test, of course, is any test that is consistent with pounding on the keyboard with the shoe, or sometimes gently placing a shoe on the keyboard. In this case, I'm going to click to make the message come up, and then I'm going to make the message go away, and I'm going to do that as fast as I can, because I'm thinking maybe some bad thing will build up and then somehow cause a crash. Well, as I'm doing that, I notice the faster I go, I get little flickers in the corner of the screen. Well, I'm distracted by those flickers, but that's okay, because that's called branching and backtracking, and we're encouraged to branch when we're doing professional exploratory testing, which, if I haven't mentioned it already, this is professional exploratory testing. So I'm going to do what Ken Kaner calls follow-up testing, which is you let yourself be distracted by some bright, shiny object, you follow up on that, you try to maximize the power of that. That also is part of the rumble strip heuristic. So I come up with a theory of this. That's called conjecture and refutation. I conjecture that perhaps this flicker is related to timing, so I begin varying the timing of my clicks and enters, and lo and behold, I find out that if I right-click on that screen within 1/5 of a second of pressing enter on that error message, I get that menu, which allows me to break into their system, which I break into. There it is. I'm in there. Picture's a little blurry there because I had to snap the picture quickly. The stormtroopers had been alerted. Sirens were going off. And so the total elapsed time to gain full control of this computer from walking up to it is 7 or 8 minutes. Now, this is the kind of thing that hackers do. This is the kind of thing that computer gamers like to do. It's the same kind of thinking. There might be some people here who've played computer games before. I don't know. I see some people who might have that that kind of dazed look of computer gamers. I discovered recently, a few weeks ago, when I took my son to an emergency software testing situation. This has never, well, it's happened to me twice now in my total career, where I get a call from a client and I feel like James Bond. I just get this call like, we need you in Los Angeles to test something. No, you don't have time to go home. We've made arrangements. Go to the airport from where you are right now. Pick up your first class ticket. But my son's with me. I was taking my son home. We live on an island, and it would take me several hours to get him home. And they said, oh, just bring him along. So 2 first-class tickets are waiting for us. We fly to L.A., and I have to do testing on a medical device for 1 day. These guys just begged me to come down. If 1 day is all you can give us, then that's what we'll take. So I thought what would happen is that my cat-like son, who occasionally will let me pet him, but mostly sits on top of a cabinet looking down at me balefully. My son I thought he would stay in the hotel room, or he would sit next to me playing World of Warcraft or something while I did the testing. But he decided he was interested in the testing, and pretty soon it turned out he's really good at investigating bugs. He's a natural at it. Maybe 13 years of figuring out video games is actually a good education, because he was looking at it as like beating a boss on level 39 or in some dungeon in Azeroth, you know. He was looking at this as a real challenge. He would find a bug. He'd say, "Oh, Dad, look." And I'd look at it and go, "Okay, can you do it in fewer steps?" He'd go, "Let me try." And he'd come back 10 minutes later and say, "I got it down to 3 steps." And I'd say, "But it shows an error message." Yeah, you can get around the error message, but can you make it happen so that the error message doesn't even show up? Because that could kill people, and that would be great if we could find one of those. He eventually found an example of a particular bug I'm thinking of that caused a multi-thousand-dollar piece of medical equipment to melt. It melted. It failed. It melted, and we confirmed from the technician that, oh, you've destroyed this piece of equipment. The good news is no one will be killed by that method now because they'll fix it, right? So we were high-fiving each other. You know, that's like one of the ultimate good things about testing medical equipment. Is if you can find something that could have killed a patient, then that's very, very good news for the tester. Bad news for everyone else. Well, sort of bad news, you know. They also don't want to go to jail, and they also don't want to kill people. But it feels like bad news to them because they go, oh, there's a problem in the product. But testers are high-fiving and going, oh, you know why testers high-five each other when they find a bug, a really bad bug? You know, it's not because we don't like developers. It's not, you know, that's what developers think, but that's not true. It's because on that day, at that moment, we go, yay, we're useful. Because most of the time, a tester doesn't feel very useful. I mean, you have to really work at it to feel useful as a tester. It's kind of like being a guidance counselor in school. I mean, most of the time you know that your life is meaningless and none of the kids are going to listen to you and all your aptitude tests are wrong. But once in a while, you know, you actually give a kid advice and then they contact you 20 years later and go, that was great advice. It changed my life, you know. And you go, wow, I was useful. Something happened and I did it right and it was useful. So testers are like that too. We often have trouble feeling useful, but when we find a huge bug, we go, yes, today they won't fire me for non-performance. So that's terrific. And maybe tomorrow I'll go back to not being able to find another bug, like a gold miner who's just wandering around with a donkey in the wilderness, hoping to make a big strike. So what I've just shown you is I've shown you a little cycle of exploratory testing using skills that video gamers have, but there's something that I showed you that video gamers don't do, that my son can't do yet. And that is, I explained what I did in specific technical language. I can tell a story of software testing that sounds effective and compelling and professional. And I wrote up an account of what my son and I did at that medical company. And I sent it to my son. I don't know if he's read it. I hope he has, because I wanted him to see, look, what you thought was just playing around with the system, look, I've turned this into this professional-looking report that makes it look like we meant to do all this stuff. Okay? And that's part of professional software testing, is to tell a story about the testing, a compelling story. And that means that you must examine the patterns by which you work. You must put words to them. Most of the terminology that I just used in describing this, I made it up. I invented that terminology. It's not part of any testing textbook. The one thing that I borrowed follow-up testing from Kem Kainer. I borrowed input constraint testing from James Whitaker. But the rest of it is all my own terminology. And I've spent years and years noticing what testers do, putting words to it, but there's a lot more of that left to do. And there's no official vocabulary of software testing, despite what the ISTQB wants to tell you. What they are doing is they're borrowing terminology from 30-year-old textbooks and saying, oh, it's standard. It's not standard. It's tremendously controversial. But they ignore the controversy. So it turns out, if you ignore enough people, everyone agrees. So, Gaddafi found that out too. If you ignore enough people, they're all in agreement. What?
He's still alive.
Yeah, that's right. He's still alive. So you know his life philosophy works great. So, here's another little example. Oh, I'm going to skip this example. I'll just skip this. I was just hacking this system and found out their secret phone number, but it's going to take too long to talk about it. So, there we go. All right, let me get on to this. I'm going to challenge you now. You've already been tricked once. At least these two guys have. I know the rest of you weren't. But these two bold gentlemen, now this time I want you to demonstrate for everyone thinking like a tester, okay? Okay, Mr. Two Tests, okay? So you're going to do it this time, because now you're on your guard. Now you know. Now you know what I'm going to do, okay? You are carrying a calculator. You drop it. Perhaps it's damaged. What might you do to test it? And this is one of the opening exercises I give to anyone who seeks to have me coach them in software testing. It's a diagnostic exercise, very simple testing exercise. You're carrying a calculator, you drop it, perhaps it's damaged. What might you do to test it? This very example was given to me years ago, and I had to answer this, and now you have to answer it. I'm focusing on you two gentlemen right here. Use it.
Only one test on off, and then it's okay.
On off, okay. Is that your final answer?
Or I'm project manager. Or I go buy a new one.
Find what?
Buy a new one.
Buy a new one. Okay.
Just to be sure.
Okay. Is anyone else have that's their answer. They've locked in their answer. Anyone else have a different answer to this question?
Was the calculator on or off when it was dropped?
Okay, so here we have a tester in the audience. Now, how can I tell that she's a tester? Because she asked a question before giving an answer, like a professional tester would do. You don't know what the situation is. You know you don't know what the situation is, so you got to find out what the situation is before you decide you know what to do. Oh, come on, guys! Was it on or off? Oh, let me just say this. I note your question. I will not answer it, but I note that you have asked it, and I will gently set that aside for the moment. Do you have any other questions that you also want me to answer for you? That's it? That's the only one? At the moment, yes. Okay, we have people calling in with more answers. Anyone else have anything else they want to say about this?
What kind of calculator was it?
Well, that's pretty important, isn't it? Because if it was an abacus, we will do different things than if it's an electronic calculator. Or if it's one of those, I used to have an adding machine. Before I ever had a computer, I had an old adding machine from 1965 that my mom got at a rummage sale at a bank. And these things didn't work. They never worked, but we just liked typing on them and pretending that we were computers, so that was exciting. If it was a calculator like that, it weighs like 40 pounds. Drop that thing, you might do something quite different. Of course, in that case, we already knew it was broken when we dropped it. If it's broken when we dropped it, and if the reason why you were carrying it was you were carrying it to the dumpster to throw it away, you're probably not going to turn it on. You're probably not going to pick it up and use it. You're probably going to just kick it toward the dumpster. And then when you get to the dumpster, maybe you'll lift it up and put it in. And knowing what state it was in at the time you dropped it might affect things, what kind of calculator it is. Sure. Anything else? Yes? What? How is that relevant? Where was it dropped? How is it relevant where you're dropping it? Ah, very good. Very good. Now notice what I did. She asked a question. I asked what is the relevance of that question. So she can't just guess questions. She has to support and defend her question. In this way, I'm finding out how she really thinks. And so if you drop it into the water, say the Indian Ocean, and it floats down 10,000 feet down into the depth, I'm probably not going to worry about testing it after that. Or maybe it's a calculator designed to sink down into the water, calculating currents or something, and I drop it, perhaps it's damaged. Well, perhaps it is damaged. It's always a possibility that the thing we designed to drop into the water might be damaged when you drop it into the water. What might we do to test it? Well, why don't we check the telemetry, because it's beaming continuous telemetry back up to us. We'll check the telemetry and we'll see if we're getting a message from it. And if not, then we'll shrug and drop another one of these things that cost €5 that we've mass-produced by the thousand. And we'll drop another one in. No big deal. We don't test it. The testing happened months ago. This is when we're using it. Well, I was asked this question years ago, and here's what I did. I spent 2 hours and I wrote a report, which I submitted back to the person who asked me the question. And this is one section of the report, one of the 3 sections of the report. Okay, well, I want to understand the assignment, and I'm aware of the possibility I've misunderstood it, so let me interpret it back to you. And I have a bunch of questions. What does it mean to drop it? When did I drop it? Did I drop it on a surface with a hard surface with a force that makes me suspect something? Did I drop it into a disruptive chemical environment, a biological environment, radiological environment? Was it connected to anything else at the time? Did I detect anything while I was dropping? It leaves me to suspect a problem. Is it ruggedized? Is it mine or someone else's? Maybe it's someone else's, and I don't want them to know I broke it. What am I using the calculator for? Maybe every calculation doesn't have to be correct anyway. Maybe it's my job to test calculators. And my answer is, I follow the test plan, of course. I dropped it as part of my drop test. Now let me offer you a couple of exhibits. Watch this. This is a calculator. Watch. Let's see if it works. Oh, it works. Yeah, I'm not really worried when I drop something like this. Of course, it depends how you drop it. Look, edge on. Wait, edge on. There, see? Kind of absorbs the impact. Huh? I did this in a store once with one of these, and it actually wouldn't work after that. But I've never seen one break since then. Here's another one. Here's a Let's Calculate children's calculator inside a protective packaging. Oh, no! I'm really not concerned about that. You know what I would do? I would just hang it back up again, and no problem at all. No problem at all. But if I were to test it, I would be constrained by the fact that I can't see all of the buttons, so I would have to restrict myself to these. So everything has a situation. Everything has a context. Testers who are good testers, they check the context before they give a technical answer to any question. There are umpty million ways to test things. There's no official right way to test anything. Instead, we have situations that we read, we interpret, and we solve the problem in those situations. Here's a requirement. This requirement is a real requirement on the medical device that I am testing. As a matter of fact, this is the one I went to LA to test. And this is one of the requirements for that. The system shall operate at an input voltage range of nominal 100 to 250 VAC. And I like to ask people, how would you test this? How would you test against this requirement if you saw it? Now, I'm not going to actually engage you. And normally in my class, I would engage people in a discussion about this and take good 10 minutes on this. What I'm going to do here now is I'm just going to tell you that here's a really bad answer. Try it with an input voltage in the range of 100 to 250. And here's why this is a bad answer. This answer requires absolutely no thinking. This is a mechanical answer. It's generated mechanically. It's just basically taking the requirement text and putting the word try it in front of it. Putting the words try it. That's essentially all that was done here. It does not actually engage the issue at all. Good testers don't just take requirements and add the word verify in front of them and then try naive things. Instead, good testers break down requirements. They model them in their heads. I look at something like that, I go, what's the system? I need to understand that system. I got to learn the system. What does it mean to operate the system? I need to learn that. Input voltage range of, okay, looks like I need some kind of special equipment to control the voltage coming into it. What's that equipment called? Turns out it's called a programmable power supply. And we have one in our shop. It's called a Variac. Yes, oh yes, we have a Variac programmable power supply. Sure, did you need one? I didn't know that. So I've got to identify the need for special equipment. Then I have to decide what I'm going to do. And notice this says 100 to 250. Well, some testers like to say, well, let's test at 90. And I go, why? Why would you test at 90? It's outside the requirement. Are you just making up requirements? Does anybody feel that we should test at 90 volts, given that this is the requirement? Does anyone here feel like it? Okay, Oliver Vilson, who's a very accomplished tester, runs a testing company, thinks we should test at 90. Anyone else think we should? All right, I'm challenging you. Tell me why. Why should we test at 90 when that is clearly outside the requirement? That's like someone saying, hey, this equipment is not designed to be smashed with a mallet. Well, I'm smashing it with a mallet then. Yes, but it's a cupcake. Now it's all over the place. Now, what have you shown? Yes, my cupcakes are smashable by mallets. Are you satisfied now, tester? Big tester, smashing cupcakes. Does that tell you anything about the quality of my product? I knew it was smashable, and now you've just shown what we already knew, that it was smashable. The thing doesn't work at 90 volts. We know it doesn't work at 90 volts. How does testing at 90 volts help us do anything? So what? We know it breaks at 90 volts. So what?
It can't break at 90 volts because power can be less than 100 volts.
Of course, but I know that it breaks. But I already know. So what? You haven't taught me anything. I told you that it doesn't operate below 100 volts.
It doesn't operate, but does it break?
What do you mean, does it break? I don't understand.
Well, it doesn't work.
You mean doesn't operate? It does not operate. It does not work under 100 volts. I knew that. I designed it. I know that it doesn't operate under. That's like saying, does this boat that you've designed work on land too? Like, no! It doesn't. Well, I want to drag it up on land just to see. No, don't do that. What did someone said something over here?
That voltage isn't so stable always. Maybe someone thinks it's 100, but actually it's below.
Well, yeah, but so what? I told you it only works when it's within this range. Why do we care to test something when we already know the answer?
How do you know it works?
What it does?
What?
What if it does work?
So what? Then it's like free extra functionality, I guess, but it doesn't have to. Why do we have to know everything? Why? Why do we have to? I already say it probably doesn't work. If it accidentally works beyond the engineering tolerance that is specified, then that's gravy. It's like an airplane might be designed to go only 150 knots, so the small airplane. And okay, maybe it won't disintegrate until you get to 165 knots, but don't fly it over 150 knots. And you put that as a do not exceed speed, and the pilot knows not to go faster than that speed. So what's the point of testing beyond situations where you know already that it won't work?
The question is, does it not work, or does it explode, killing a lot of people?
Finally, you say something that's brilliant. Thank you. I knew if I gave you 3 chances, the third one would work. He's got it. You see, it's not just that the system, it fails outside the requirement. We know it's going to fail outside the requirement. If it doesn't fail, then we would go, oh, well, it doesn't fail, but we don't expect it to work. But that's not the issue. The issue is that there's another requirement, an unwritten requirement. It's usually not written, and it goes like this: thou shalt not kill. It's one of the commandments, I guess. And so this is a medical device, and okay, I know it's not going to work, but the question is does it fail to work in a way that is dangerous to the patient, or does it gracefully fail and stop itself from hurting people? In other words, I know that if I fall asleep at the wheel of my car, I'm in a dangerous situation. What I want to check is, if the driver is very tired, does the driver detect that the driver is very tired, and does the driver pull over and take a nap? Or does the driver just fall asleep at the wheel? You know, I want to know what happens when we take it down to that level. You're not inventing requirements. Notice that I'm not testing outside the requirement. I never test outside requirements, but I do test unwritten requirements. They're real requirements. And if it explodes, that would violate a requirement that may not be written, but it darn well is important. So what I'm saying here is that every time I look at requirements as a tester, I don't just numbly copy them into something called a test case. It's not simple like that. Instead, I'm questioning it, I'm modeling it in my mind, I'm imagining different ways it might interact with other things, and in so doing, I'm expanding the world beyond what is written down explicitly for me. That's a big part of a tester's job, to make the world clear. So you have something which is the world that is described. That's the world that's in the spec, right? And you have something that is the actual world. And the tester's job is to compare the actual world to the world that's described. But this isn't the whole story, is it? There's more to it than that, because we also are interested in the imagined world. People have ideas in their head. Some of those ideas get explicitly written down, and other ones never get explicitly written down. The tester must be aware that the spec they're looking at is but a slice of the world that they must cope with. So I'm testing the actual against the imagined. In other words, the actual world against the intended world, and as well as testing it against the described world. And any of these areas of the Venn diagram are interesting for testers. There might be a situation, for instance, where the product actually works the way it's described to work, but that's not how the programmer intended it. And here's an example. The programmer says, this web page is going to be compatible with Firefox browser. And then they create something that happens to be compatible with the Firefox browser, even though they have no idea what it actually means to be compatible with the Firefox browser. Now, how is that possible? The developer could accidentally create something that fulfills a requirement that they don't even understand. Well, it happens all the time when people use libraries. They may use an application framework that is already designed to be compatible. Now, all that's fine. You know, you can have a developer accidentally achieve a requirement they don't understand. The problem happens when they, at some later point, change something, and then it stops being compatible, but they don't think they changed anything that made it incompatible. Testers are there to catch situations like that. Testers catch all kinds of interesting situations, and one of the things that testers do is they help educate the developer about how their own technology works. You could say that testing is just the process of try it and see if it works. But this is very complicated. There's lots to this idea of try it and see if it works. And it's kind of an infinite process. So I prefer to use this phrase. I say, try the product to learn how it might not work. That gives an edge to testing. I'm constantly focused on how the product might fail. By doing that, I maximize the chance that I will find useful information for my clients. Now, what I'm trying to illustrate here with these different examples that I've been reading off are the following things. Okay, you've seen audaciousness. Testers must be audacious. Testers must say, I know you think it works, but I think it might not work. I think I can find a way to make it not work. I might fail, but I will audaciously try. I use my imagination. I question. I'm rapidly learning about anything I encounter. I'm making sense of what happens and creating stories out of that. I'm telling those stories. You've also seen focusing and defocusing, which are fundamental dynamics of testing. Sometimes I must focus, which means I must look at a very narrow thing very carefully. And other times I defocus, which means I stop looking at whatever I've looked at and I'm now going to look at something different. I use heuristics as well. Heuristics are ways of solving problems that may not work. In other words, they are fallible ways of solving problems. I don't do any best practices. There's no such thing as a best practice. Actually, if you ever hear anyone talking about best practice, they are not engineers, they are marketers. Engineers know that each solution that you might suggest is relative to the context of the problem. That's why doctors don't have the best medicines. They have medicines that they prescribe for specific illnesses and specific situations, and they ask you all these questions to make sure that this medicine probably will help you. They don't say, oh, I'm so bored hearing your symptoms. Look, take aspirin. It's the best practice medicine. So there's no best practices. What there are, though, is there's skills, there are heuristics, there are context variables, and testers, when they're crafting their tests and they're crafting their test strategy, they must be aware of these things. Constantly feeling out the weak spots of a product, constantly reanalyzing risk. I love it. It's like detective work. It's the most ultimate detective work in multi-dimensions. It's wonderful. And it's not just one murder. There are hundreds of murders to solve for this detective. This complicated looking diagram is what I do whenever I sit down and even play with software for a few minutes. I'm going through all these loops. I'm referring to my knowledge. I'm analyzing what I know. I come up with experiments. I ask questions of the product. I get answers. I form my testing story, which then guides my testing. I check with other people, and their ideas guide me. Lots of complicated things are going on. Even if I never write down a test, even if I never make a mark on a piece of paper, even if I just stand here and test off the top of my head, all these complicated things are going on. Testing is a highly interestingly structured activity, even if you do it entirely improvisationally, entirely ad hoc. It's still a highly structured activity. Sometimes people use the word structure when they're trying to criticize the things that I do. They go, well, I use a structured approach. What they mean by that is they use an approach where they understand the structure of it. And they don't understand the structure of my approach, so they go, oh, there's no structure there. It's kind of like a giant cockroach standing next to you going, I have a skeleton unlike you. And you say, well, I have a skeleton. And they go, you look pretty squishy to me. And you go like, no, I see the confusion, giant cockroach. You have what's called an exoskeleton. Your structure is clearly visible to the outside eye. I have what's called an endoskeleton. My structure is within. And they go, oh, you're just using rhetorical tactics to try to fool me. You really have no structure. You're like a jellyfish, aren't you? And then you punch the cockroach and spray raid at it and kill it. And you don't have to worry about that anymore. Also, giant cockroaches can't live very long because they can't breathe well when they're that big. So don't worry about it. Now there's 4 loops. There's 4 loops. There's a self-management loop here. There's a testing loop, looping between analysis and experiment. There's a learning loop, looping between knowledge and analysis. There's a collaboration loop between analysis and other people. These loops are all part of professional exploratory testing, and most of testing is exploratory. There are lots of people, you'll run across people like this if you read any books about testing or if you take testing classes at institutions like this. You're going to hear a lot about test cases. You're going to hear a lot about writing down tests. And most of testing is not written down. Most of testing remains tacit. Only a small part of it ever gets written down. And to write down a test makes that test vastly more expensive. So it's a dangerous thing to write down tests. Economically, it's very dangerous. I mean, imagine that you could only eat something if you log a description of it before you eat it. It's not just that you say, I had mashed potatoes. It's you have to draw a picture of the mashed potatoes, and then you're allowed to eat it. Okay? Eating would become quite expensive. It would become this big production. And you would probably do a lot of secret eating, kind of off the books, or else you'd starve to death. I don't want to make testing so expensive that people won't do it. But if I insist on making my testers write down their tests before they run them, I am making testing expensive, and that means I'm limiting the kinds of tests that they will ever do. And they'll do a lot less tests. They'll do a lot less variety of testing if I insist on trying to document all this stuff. So the art of test documentation is actually an interesting and challenging art. How can we minimize the cost of documentation? How can we minimize documentation entirely? How can we maximize the value of the skills that we have? If anyone here drives a car, you already know that you do this because you were trained to drive a car instead of being given a set of instructions that you have to carefully follow so that they wouldn't have to train you. And then you follow the instructions, you go 10 feet, you stop. Then you read the instructions again, go 10 feet and stop. I mean, your driving would be incredibly slow and inefficient if instead of training you to drive the car, somebody tried to control you with a script. So, I recommend the book if you want to know all about this. There's a brilliant book about this, several of them actually. There's one called The Social Life of Information, which is based on a study of how people learn to repair copy machines at Xerox. And there's another one I just read called Tacit and Explicit Knowledge, which is a brilliant analysis of the difference between what can be explained, what can be put into words, that's knowledge, and what cannot be put into words as knowledge. Now you're holding up a blank piece of paper. What does that blank piece of paper mean?
15 minutes.
It means 15 minutes. Okay, I gotta go faster here. Okay, I talked about rapid learning. I want to give you an example of rapid learning that I do as a tester. A friend of mine sent me a link to something about space-filling curves, specifically Sierpinski space-filling curves that are being used to solve the traveling salesman problem. And I thought, interesting, maybe I can use it to solve other testing problems. If you can solve a coverage problem with a space-filling curve, maybe I can solve a test coverage problem with a Sierpinski space-filling curve. So I worked on that for about an hour and couldn't think of a way to do it. But while I was doing that, I discovered about L systems and Penrose tiles. And Penrose tiles are interesting because they're non-repeating patterns. And I thought, non-repeating patterns, I can use those in testing maybe. And then I couldn't think of a way to use them. So I went over to the traveling salesman problem and I decided, well, there's got to be apps that solve the traveling salesman problem. I can learn more about it. So I went to this place that had a bunch of physics apps, and one of them was an app for diffusion limited aggregation, which is totally fascinating and relates to learning but has nothing to do with testing right now, so forget about that. And then I went over to simulated annealing, which is right next to the thing I was looking for. Simulated annealing is a method of solving the traveling salesman problem. And when I found out about that, I realized that I had learned a technique of software testing that I'm now waiting to use. In fact, I think I have used a technique much like this. Simulated annealing is a process of using random testing to solve a problem. It's a formalization of exploratory software testing. Here's an example of the thing working. This is the little algorithm trying to solve the traveling salesman problem. It's trying to calculate the shortest path through this set of random points. And the way simulated annealing works is that first it's very random, and then it slowly becomes less random. It sort of turns down the temperature is what what they're trying to do, meaning that they perturb the path by less and less and less. And in this way, you avoid a local minimum, a purely local minimum, and you get closer to the global minimum. And it's pretty cool. But this is an analogy that also has a lot to do with testing. What I'm trying to say is, as a tester, what I'm constantly doing is I'm exploring ideas from physics, from mathematics, from all walks of life, and I'm trying to use that to invent new solutions to testing problems that I might face in the future. What I love about testing is I am constantly learning about cool, deep, new things. This whole process of discovering why no two snowflakes could ever be alike, I found out why that's actually true. I always thought it was kind of a myth, but it turns out mathematically that it's rather true. For the length of the entire universe will be, the time that the universe will be in existence, there will never be any two exactly identical snowflakes that are visible to the naked eye. And I found out why after I was learning about diffusion limited aggregation. So all this whole process took me 4 hours to go through, and then this happened 3 years ago, and this is just one of many, many, many little learning events that I go through as a tester. Testing is full of self-education. Oh, I told you not to count test cases? Yeah, that's you don't count test cases, and here's why. It's just like counting unicorns. If I asked you how many unicorns would fit in your bedroom, and I asked this of someone in Sweden once, and she had this faraway look in her eye, and then she said, 2, I think. It's like she was really working on this problem, you know. She's trying to figure out, now if I put this unicorn in this way and then tuck it up against the wall, I can lead the other one in. I guess she wasn't thinking about the unicorns that teleport. The thing is that if you calculate it, it all depends on what you mean by a unicorn. And it's the same thing with test cases. You see, their test cases are tiny and test cases are huge, or test cases are copies of other test cases. And if you think of a unicorn as the letters UNICORN put into a text file, copied 100,000 times, put in a directory with 10 other files like that, shrunk with 7-zip, packed onto a 32 gig thumb drive, and then packed into 1 cubic meter area, my calculations say you can fit 15 petacorns in a 1 cubic meter area, or 15 quadrillion unicorns, each independently addressable. Example. And of course, anyone who has studied data compression knows that there's a much better way to fit more unicorns, and that is just to write on a piece of paper a 1 times 10, followed by some number like 10 to the 1 billionth power, or however many long you want, and then just say instances of unicorn, and there, you've got data compression right there. That's a piece of paper that has as many unicorns on it as you want. But my solution is independently addressable instances of the word unicorn. When you count test cases, you're not counting anything. You're counting fluff. You're counting ideas, because test cases are not independent. They're not interchangeable. Now, this brings me to test automation, because some of you might be thinking, well, why don't we just make the computers test themselves? And that way, we can watch them fight each other like gladiators. And we can be the humans in the stands going yay or nay to them. And that the computers are testing each other. Isn't that marvelous? Well, it's not marvelous. Here's why. Imagine that, well, you know, my wife, she likes it when I say things like, I love you and all that stuff, right? So, been married 20 years. You got to know about this stuff. I could create a cron task that would just send her an email every hour saying this. She doesn't like that. So that's what I get. I don't get the credit, okay, for making it extremely efficient to remind her of this fact that she seems to find very suspiciously easy to forget. It's the same thing with testing. My boss might be comforted by me running tests over and over and over again. So I might write a little automation thing, and then it's just running this action over and over and over again. But here's the problem. The problem is that when you do actions over and over and over again, that's not a test. That's just an action. The test was the tester thinking at the time of doing the test, and that cannot be automated. Now, the action might have some value, might definitely have some value in and of itself. You might say, I'm going to run a task that just says, is the website still up? 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 And maybe it'll go down, and maybe I'll find out that it's gone down. And maybe that's a good thing that I found out that it's going down. But it's not testing. I think what we should call it is checking. That's checking. Any fact that you can gather with a computer should not be called testing. It should be called checking. Because it will help us not get confused. Because what a tester does when a tester checks that fact is not just checking that fact. When you personally look to see if the website is up, as opposed to having your script do it, you not only will check if the website is up, you'll also start noticing things like, the website's getting slower and slower to load. That's odd. I brought the website up and it comes up, but part of it's changed. I think we've been hacked. Or, the 100th time you bring it up, you might say, I never noticed this before. I just realized it's been happening all along, but I think this is misaligned. I think this paragraph's misaligned with that. Or this isn't being rendered correctly. I just realized it. Well, that program that you wrote to do that checking, it will never spontaneously change itself to a program that will start noticing things it's never noticed before. But humans will. A human tester who is trying their best to act like a robot will probably fail, and probably some humanity will get through. But if you're trying not to act like a robot, even more likely, you will learn something new the 10th time you run what you think is the same test. But your program will never learn. Your program is not doing testing. Your program is just performing a behavior, which can help testing. I use test automation, don't get me wrong. It's just that test automation is not automating testing. It's automation in support of testing. I mean, here's the thing, though. Here's why it's so hard to explain this to people. Because managers think testing is this. They go, hey, look at these clean white plates and just tell me if there's a bug on it, okay? I mean, surely it's easy. Just glance at it. You'll see if there's a bug on it, you know? What's so hard? Testers constantly complain about this. It's so easy. Look, I can look at the plate. There's no bug on it. And I go, yes, my esteemed manager, but that's not the testing problem. This is the testing problem. I'm testing the professional kitchen for bugs. This is a very complex space to cover. It's a very dynamic space. This is a very simple space, very narrow space. When people don't understand testing, they think testing is like this. Just look at it. What's so hard? When people understand testing, they realize it's more like this. So here's the thing. Developers, they have already figured out that they should not call things programming if a computer does it. You never hear the programmer saying, I'm going to have the auto programmer take my source file and prepare a program from it. No, they call it compiling. But what is a compiler? It's automated programming. So what programmers have done for years and years and years is as soon as they make a tool to automate programming, they don't call it programming. Programming gets redefined to whatever the programmer does, that's what programming is. I'm doing the same thing. We should call testing whatever it is that testers do, and anything else that supports that, give it a different name. I prefer to use the term checking to remind myself. Every time I say checking, I remember the automated checks can't use judgment and they never learn or evolve. They might be very helpful, but they're not humans. And therefore, we should not get too confident about what automated tests can show us. Recently, the performance tester, there's one performance tester for Facebook. Okay? One person who does that. Her name is Garanka Biedov. And she told me that her bosses told her that she had to automate looking at the graphs, the performance graphs. And she said, no, that's a bad idea. And they said, well, it's okay, we'll have this other guy do it then. So they had this other guy automate looking at the graphs so that they wouldn't even have to look at the performance graphs. Shortly thereafter, Facebook suffered a major performance problem that was not caught because the person who automated looking at the graphs didn't put any alert in case the performance got better, but only if the performance got worse. So one day the performance tests are running, or one evening they're running, and suddenly performance is improved by something like 3 times. It's suddenly 3 times faster than it was yesterday. And a human tester would go, that can't be right. Something has to be broken in the tests. In fact, it wasn't running some of the tests. But the automated graph reader just said, cool, no problem. It's even farther away from the red zone. So they never got clued in until people started saying, wait a minute, there's something wrong with Facebook. I don't know what happened after that, but I haven't talked to Garanka since then, but I think they pulled out those automation checks now, and they have a human look at it. That's what us humans, that's what we're good at. Okay, I'm not going to say too much about testers being like Tamagotchi. This is something for developers, and there's a little bug in the Tamagotchi site anyway. A tester must develop their reputation in order to be effective on a project. It's very, very important. Developing a reputation. This comes from the book The Prince. You know, the prince must give striking proofs of his capacity. And I wrote a book about being a buccaneer scholar, which applies the kind of the concept of the pirate world to learning throughout your life. So I applied this to buccaneering. Here's a little segment from the book Buccaneers of America, and I like this because it kind of relates to me. It's about this famous buccaneer, and notice what it says. It says, though in his private affairs he governed himself very well, he would oftentimes appear brutal and foolish when in drink, running up and down the streets, beating or wounding those he met, no person daring to make any resistance. So I, as a tester, I'm like that. Though in my private affairs I govern myself very well. I work hard to develop a reputation as a tester that he can test anything. That he walks into the room and the bugs just surrender. Like the first Gulf War. They just surrender. They'll surrender to his boots. I want people to think of me that way as a tester, and that's what you need to do if you're going to develop yourself as a career as a tester. You need to practice testing. You need to be like Miyamoto Musashi. You need to become a famous testing duelist, and there are ways to do this. There are communities that will help you do this. I can introduce you to those communities. And if you do this, you can easily get, at this point in the world of testing, you can easily achieve, with some work, an international reputation as a tester. Right now, for instance, as far as I know, there's one tester in Bangladesh. Now, there's probably a lot more testers in Bangladesh, but there's one who has an international reputation, and I know his name, Sajidul Hakim. And that's just because he blogs and the rest of them don't. And he makes up interesting new ideas, and the rest of them don't. And there's one tester, as far as I know, in Germany. I'm sure there are more testers in Germany, but there's only one that has an international reputation in my community. There more could, but they choose not to. In Estonia, there are several. There's Christian Uba, who's here in the audience, who's a internationally known tester, and Oliver Wilson, who's internationally known. And those are the two so far, although there are some people working for Oliver who deserve to have international reputations. I don't see their blogs, so I don't know. And, there's also Are, although I'm always afraid to say your name because I can't pronounce it. So it's something like Are, Ore. Kind of like Oreo with the letters mixed up. There was someone in Israel, there was a secretary in Israel I had to deal with when I was teaching there, and her name was Chen. And I would say that. I'd say, Chen. And they go, what? Who is that? And they go like, Chen. And they would say, oh, you mean Hen? And I'm like, yeah, that's what I said. They're like, no, you didn't say that. You said something different. You said like pinball or something. We don't know what that is, but you went, Hen. I'm like, there's some kind of ultrasonic sound I can't make. Oh, it drives me nuts. One last thing. Here's my last thing. Whenever I show up as a tester and I want to establish my reputation with developers, I do several things to do my striking proofs of my capacity so that they know they're dealing with someone who's an intellectual, who's a rapid learner, who is no lightweight. And I've worked many years not to be a lightweight. One of the things I do to disarm the developer and charm them into submission is I give them a piece of paper and it has 13 commitments on it. I say, these are my promises to you, sir. And they've never, ever received this from a tester before. No one I've given this to has ever encountered a tester who has ever made any promises or commitments to them. But that's what I do. I provide a service. You're an important client of that service. I'm not satisfied unless you are satisfied. If you're unhappy with my work, I'm unhappy with my work. There, I said it. I'm not the race car driver. I'm the pit crew guy. I know that. I don't have to deal with spinning off the track and crashing. You're the guy who puts the bugs in the product. You know, testers like to say they break the product. I know I don't break the product. I know you spent all night breaking that product, and I'm just noticing the result of your work. I didn't break it. So the pressure's not on me. Pressure's not on me. I know that. So I support you. All the pressure's on you, developer, and I'm going to help you with that pressure. I'm going to support you. I'm going to be the guy you can count on to try to see the best in your software, and also to help you notice how there might be some things that other people won't like in it. Not me. I mean, I love you, but they don't love you like I love you. So let's keep it in the family. Show me the product, developer. I'll complain about it, but you know I love you. It's okay. You can hear complaints from me. Look, when I'm about to leave the house and my wife says, hey, there's a little bit of mustard on your chin, I don't go, oh, how embarrassing. I go, thanks, honey. That's your job. I expect you to do that. Thank you very much. She wants me to look my best. I didn't buy these clothes. I don't know about clothes buying. She figured all that stuff out. So I just wear it and I hope for the best. And if it's not the best, it's her fault. She's support crew for me in that respect. I can't do what I do unless she does what she does. And I support developers I work with. So I make a list of all these things that I promise to do. I'm going to learn on my own as much as possible. I'm going to try and find important problems quickly. I'm going to write clear, respectful problem reports. I'm going to if you have special requests, developer, I'm going to try to fulfill those special requests. I will never fake my work. I will always do work that I think is real and useful. And if I'm asked to fake my work, which I sometimes am, I refuse to do it. You will be asked to fake your work too. Everybody is asked to in their career. When I say fake your work, someone will say something like, create a bunch of test scripts, written test scripts, and you'll go, but I really can't do that because the product's really not designed yet. But our process says you have to create the scripts, so just to do something. And my response is no. I will not do that. I will not make documentation that is useless. Under any circumstances, I will never do that because you pay me too much. But if you only paid me, let's say, €2 an hour, I'd be happy to do any fake work you want. But you pay me so much money that I must only do my best work and not waste your time or anyone else's or pretend to do things that can't be done. This is stuff that's hard to say to your employer when you're new and young. But the older you get, the easier it gets, I find, and the less patience you have for bad work. Okay, well, let me just wrap this up. What I've tried to show you is some of the thought processes that go into being an excellent tester. You need to think laterally. You need to think vertically. You need to learn things quickly. You need to become excellent at asking questions. You need to model products in your mind and respond to those models. I haven't had time to demonstrate some of the finer points of test design and that sort of thing, but I have demonstrated some examples of testing and specifically talking about testing, because your ability to talk about your testing is critical to how well you are thought of as a tester. Google me. You'll find out that I am considered a world expert in software testing. You'll find out if you count the hits. Not that they matter, but I do get the most. I get more hits than anyone with respect to software testing. Type in anyone's name. It could be like Mahatma Gandhi. Oh, I blow him away. Like, great man, not in software testing. Okay? Like, how about Julius Caesar? No reputation at all as a tester. Okay? Compared to me. So I have a reputation as a tester. People think I'm a great tester. It's not because I am a great tester, because they don't know. They've never seen me test. All these people citing my work, they've never seen me test. Or maybe a few of them have here and there once in a while. They see glimpses. Why do they think I'm a great tester? Because I talk really well about testing. I'm aware that that's not the same thing as being a great tester. So I have a secret program that I'm working on secretly, which is to actually be a great tester. And I work on that really hard because I don't want to be exposed as a fraud. But the thing is there are a lot of people who are really great testers, and they are unknown in the industry. Unknown. Because they don't know how to talk and explain themselves. So I encourage you, first of all, come into the world of testing. I think you'll enjoy it. If you are a strongly intellectual person with a short attention span who loves to learn new things all the time and solve puzzles, then you'll really enjoy being in testing. And if you have some development skills, all the better. And a lot less pressure is on you than will be on you if you try to build things. If you are going to be a developer, try to insist on getting testers who work for you or work with you who are intellectual, rapid learners who like to solve puzzles. We need to hold testers to a higher standard. And as you encounter the ISTQB, I hope you will notice, as I have, that it is almost content-free and says nothing whatsoever about skills and pretends as if testing is all a bunch of words that you have to memorize. And most of the words will be rather useless, I predict. But maybe some of them will be useful. I just think if you never heard of the ISTQB, you'll be better off. And you'll be a better tester, and you'll be more educated than if you study the ISTQB syllabus, which is 40 years out of date. All right. That's what I have to say. That's my challenge to you from across the great Atlantic Sea. Good luck, and I hope that you could get out there and get involved in the testing community. Thank you very much.